Oh, g'day champions, we're back with that Studio 22 Mesa Boogie thing. I'm going to remove that board for easy access to both sides and to install some turrets and just give the thing a great clean and inspect it. It's just a bit easy to work on it. The more you bend it in and outwards, the more chance you're going to get of snapping wires and stuff and just fraying things in general. We're going to do a recap. We're going to fix up that dodgy work. We're going to replace the carbon comps. We're going to replace the failure-prone tantalum capacitors, and I'm going to do a few other reliability mods. We're going to reduce the amount of hiss from the thing. They've stolen a bit of a fender circuit, but whacked it in front of all the gain stages, which is it takes special talent to make a clean channel noisier than a dirty channel, but they managed it. So anyway, we'll address that, and yeah, as I say, a few reliability mods, and check where the bias point's at, because these things have a pretty retarded way of biasing the output valves as well. So I'll run you through all that. Hopefully I have time to pull out the schematic and give you a little bit of a look at the horror, and then we'll get it up and running and refine it from there if required. So I hope you enjoy.
So this particular amp is a bit of a pain to work on, because to do any major work, you've got to remove the board, and to remove the board, you've got to remove a lot of solder connections. In this case, I've decided to just remove the entire board because I'm working on, a large percentage of it. But if you just want to get in there and change just one thing, for example, the bias point or whatever, you've got to disconnect like 8 wires and undo all the standoffs and swing it up out of the way. So it's a bit of a pain and time consuming, but that's Mesa.
All right, freedom, horrible freedom. Put the chassis aside for cleaning later and access to the EQ boards, but for now we'll focus on the main board. So interestingly, the middle pot's wiper had this bit of bus wire connecting it to the base pot, and it wasn't connected. It's like someone's desoldered it and never resoldered it, and yeah, that would have presented issues. So this is because this amp was brought in non-functional, we're probably going to discover all sorts of weird behavior and other secondary issues that need addressing once it's in a functional state. So I'm kind of factoring in a bit of time after we've reinstalled this board to maybe even take it back out again and look for extra issues. But we'll test the most we can passively while the board's out. But there's only so much you can glean from a board sitting on your bench as opposed to an operating tube amplifier, as you seppos say. There's a closer look at the component side. You can see all the discoloration and everything. That's a bit clear around this area. I've seen a lot worse, but that's not great. And obviously the damage there from a failed resistor in bygone days. So I think I'll take another photo or two, and then we'll start snipping. We'll remove all the parts we're going to remove, clean out their solder eyelets, or the holes, and clean both surfaces of the board as best we can, as well as the valve sockets, and retension them, and then start repopulating where required. Alright, so we're just about ready to start snippety-doo-dah-daying. As I remove the components, I'm going to tick them off on the schematic, because if we just follow this later, Mesa Boogie schematics are very well known for having errors all over them, whether that be intentionally to try and stop people from cloning them or something, or if it's just incompetence, so we shall never know. But what I will do is just mark down, put a little tick next to each component if it is actually what it says it is, or if it's not, I'll write the actual value of the actual part on the actual board that we've actually got here. Alright, starting with our filter caps, 30 microfarad 450 volt, that's all as it is on the schematic. Actually used a bit of silicon, they do get points for that. Did I just praise Mesa? So regardless, all that's coming out, so snippety-doo-dah. All the damn day. All the dopey carbon comps can come out. These pads on all Mesas, even current model ones, they're not pads, they're may as well not even be pads. They're like tubes. The pads are so tiny, non-existent, that you disturb them, you look at them funny, and they vaporize, they disappear off the face of the earth. So we do not want to give this board any excuse to be any worse than it already is. So we're going to tread very lightly, as you have to do with Mesas, because they're special little boys. And we're going to make sure we don't damage the traces any more than they already are. Every turret that you got to put in is extra work. You got to drill a hole out. You got to ream the or rivet over the turret using the little mandrel they give you, and a weight to back it up with a hammer on the other side. And then you got to usually clean up the area, maybe strip some solder mask, find a place to run the wire to, and then put all of that before you can install the component back where it used to be. Now, I don't like that coupling cap either. That was the one I said was touching the board. It's hugging another component, but we should be able to snip it from this side and sacrifice it. Now we get started on the tantalums. They're hiding down a little bit lower than everything else. So I'm just going to go ahead and do all of this. I'm not going to tell you the value of every single one on the video. As relaxing as that sounds. Okay, maybe just one more. C202, another 3.3 microfarad, and it's 3 microfarad on the schematic. Yep, happy days. Off we go. So that one looks like it's been replaced already, so we've probably already had 1 or 2 fail in here. They're all just little time bombs, those little bastards. Now another thing common to Mesa boogies, you can't help but laugh. You've got EL84s and they've got 390 volts on the plates, which is ridiculous. That's just asking for arc over and just destroying valves and burning shit out left, right and centre, blowing up your screen, grid resistors, you name it. And they've also quoted down here 230 volt primary. So when we're running on 240, 245, 255, that voltage pushes up to like 420 volts on an EL84. What do you think's going to happen? Oh, that's the critical word, think. They don't. Now, of course, someone's going to go, oh, I've had one of these for years and it's got the original valves in it. Well, good for you, but data sheets are data sheets. Stick to them, otherwise shit blows up. It may not blow up 100% of the time, but it blows up much more often than if you followed the data sheet. Yeah? You can't argue with that. Now, in a lot of other Mesa amps, this one's not as critical, but they've used 400 volt coupling caps here. And you've got like 296 it quotes, but it's probably more like 320 or something. And you got minus something, 12 volts. It says here on the grids of the output valves, the bias supply. So you've got about, say, worst case scenario, 330 odd volts across the coupling caps. Not the end of the world with this model, but with other ones with high plate voltage and say 6L6s on the output, and a more negative bias supply voltage, you've exceeded the 400 volt cap rating, and it's like they don't know what voltage is across these caps, so they just keep putting it even up to the Mark 5. I haven't seen a Mark 7 yet, but the Mark 5s, what happened to Mark 6 anyway? Did they just throw them all straight in the bin? I hope so. But anyway, they use 400 volt caps that have like 450 volts across them with, predictable results. So they go short circuit and then they take out your output stage 2 because the valves just conduct themselves into oblivion and often take out the output transformer there. We get away with 400 volt caps there, so that should be fine. As long as they're not leaking, we can leave them in. Alright, champions, I'm just going to go ahead and clean up all the pads and the holes now. Get the old leads out. Give it some fresh solder and give it a bit of a clean, and reflow any other suspect joints that we see in the process. To do that, we're going to fire up the BOFA so I don't choke on flux and piss smell. Some of the connections where the component's gotten really hot, it's actually turned the solder to like this grey crusty mass. It's not the worst Mesa board that I've seen though. I've seen a lot worse. I had one where this black slime came out of the board every time the soldering iron touched it. I don't know what the hell that was. I think caps had exploded and spread electrolyte all through the amp previously, and someone had replaced the cap, but all the residue had been left behind and they just soldered over it. So quality technician there. Some of these pads on the ground planes take a lot of heat because they haven't progressed to 1983 technology yet and introduced thermal landings. I forget what they're called. Essentially, you've got the pin, and then there's a gap all around it, and only a few little tabs that connect the ground plane to the pad, and that allows you to get heat into the pad, and the heat doesn't get immediately sucked away by the mass of the ground plane. Yeah, I think Mesa still don't know about them, even though it's 1973 technology. Trying to melt the solder on this side, that this ground plane is sucking all the heat out of this pad. There's another ground plane on the other pad connected via the through hole. It's impossible to melt the solder on this side while melting the solder on the other side at the same time, because this just sucks all the heat straight out of that pad. So yeah, that's really shitty PCB design, and it makes servicing and repair really difficult, which is probably why PCBs get damaged in these things so often by well-meaning techs. Now, if you are going to do a ground plane, and 9 times out of 10 it's not necessary, but if you're totally committed to a ground plane, here's the pad, here's the ground plane. See this little gap? Even though it's connected by those 3 little tabs, that allows the pad and the through hole to get hot enough for it to melt the solder without pumping too much heat into the thing. You can actually solder at a lower temperature as a result. That's the way you do it, and in all the CAD packages I've ever used, that's automatic. That just happens when you've got a pad in a ground plane that's connected to the same net. So it's not difficult. They should just upgrade their software, mate, because I've seen new boards from Mesa and they're still doing the same thing. And now's the tricky part, because I've tinned my pads over here and I need to be able to visualize where they are on the other side of the board somehow. Someone's put a jumper there. I think that's a board layout problem. That's the heater balance resistors. They should be connected both to ground there. Someone stuffed up the board layout. I'll just go through and give all the valve sockets a reflow. During the process of cleaning up the board, I've also just been keeping an eye out for anything that doesn't look original, and down here we've got one of the plate resistors for the PI replaced. It looks like a 1/4 watt carbon film, and the original down there, which looks like 1/2 watt metal film. Both are the correct value. This one looks discoloured, like maybe it's had a fault in the past of like the PI valve being biased too hot for whatever reason, or shorted valve or whatever. And this one's been replaced, so I might upgrade both of them to like 1 watt. The values are a bit weird. You got 120k and 68k. I don't know if that was just Randall picking out values out of thin air, if there's a real reason for that. So we'll go with the original values, but just a higher power resistor, and lift it off the board a little, because you've got some heater traces directly underneath them. And I do not trust this solder mask as far as I can throw it. Alright, so I've removed pretty much everything I want to remove. There may be more things once we've tested it that I'll want to address, but it's a good start, and time to start cleaning the board. So I've got a bit of pure, well not pure, but 99.99997% isopropyl, so that's electronics grade isopropyl alcohol. We're going to clean off this dirt and the flux. I will give the bottom of the board another cleaning cycle once we've repopulated it to remove the flux that is deposited by the new solder, the fresh solder that I'm gonna use. But we'll just get as much crap off as we can. This burn area of the board, it's due to the EL84s being basically overheated. This amplifier, we'll run over this later, but this amplifier is right on a knife edge in terms of the plate voltage on the EL84s and the bias point of those valves. So it's already, well, Mesas tend to be either over dissipating with EL84s by like 150%, or all their 6L6 amps seem to be biased at like 15 to 30%. I don't know. Look, trying to apply logic to Mesa is like trying to herd cats. It's not going to happen. So this one, if you try to cool down the bias too much, the plate voltage, which is already way too high, goes even higher because you're putting less load on the power supply. So you kind of need to run them over dissipating a bit in order to not have the plate voltage go so high that you end up arcing valves. EL84s tend to be, the most delicate part of them tends to be the screen grid. So if we control the screen grid current and voltage, generally you can abuse them a little bit on the plate voltage and they stand up to it. So we might modify the screen supply in this amplifier to at least drop the screen voltage a bit, and maybe have a chance of getting more than a couple of months out of a new set of EL84s. But anyway, that was a big tangent, so let's just clean this thing for now. One for you, one for me. Don't do that. Isopropyl, the smell makes me kind of nostalgic because Dad had a electronics and, well, mainly computer repair business back in the day, and there was always one of these little push pumps of isopropyl there, and I'd clean things after I soldered them or whatever, and it was the smell of electronics to me. Still is. So I'll let that soak in a bit just to soften up the crunchy bits, and we'll give it a few cleaning cycles of blasting off with compressed air and patting it down, seeing how well it's cleaned up, and then repeating the cycle a few times, and then we'll do the same to the other side of the board as well. Alright, champions, here we are with the board cleaned, repopulated, a few little secret squirrel mods there. Cleaned on the bottom side, turrets installed where we've needed them, and broken solder joints and whatever reflowed, all the valve pins reflowed. Nice and clean. Can't really get rid of that sort of discoloration from the darkening of the fiberglass, because that's literally within the fiberglass itself, but it's not conducting, so I've never seen one of these boards actually conduct no matter how dark they get. So that's good. We've got all the new caps, silicon to the board, the large ones anyway. Let's run through the nitty gritty. So all the tantalums have been replaced with axials. New bank of filter caps there for the low voltage supply. New filter caps there for the high voltage supply. We've got that 1K for the low voltage supply mounted on turrets where the pads were vaporized. Carbon comps have been replaced by metal films. Sometimes up the wattage a little bit just to get some greater surface area there for heat dissipation. Screen grid's upgraded to 1.2K, 2 watt metal film, and that's the first screen dropper there. We'll see where the screen voltages sit with this 5.6 as per the stock circuit, and the 1.2K is there as well, and if we need to we can change the value of that, maybe by 1 notch. So what's all this? We changed the output stage. They've actually, I think, unintentionally created a voltage divider right before each EL84, so we've rejigged that so it's a proper grid stopper. The 220K there, and then the 2.2 meg to ground the grid leak prior to it. I don't like using orange drops at all generally, but I do keep some on hand for this kind of stuff where I wanted to bridge across, well, not bridge, but mount the capacitor above these tracks but have a bit of isolation between them, so the leads on a Panasonic or whatever would have been maybe touching if it got pushed downwards, as it was in the first video. having this lead spacing here on these components is pretty handy because it spans the correct distance between those pads without having any excess lead that could maybe vibrate and break through that solder mask there. And I've upgraded the mix resistor there with its bright cap. Nice V-shape model and a low tolerance metal film there. Hopefully reduce the noise and microphonics in that very sensitive stage. Now I've replaced the heater balance resistors with actual fusible resistors, so if anything goes wrong they'll go open in a more graceful way than the carbon films that were in there before. So I'll give the pots a clean while it's out, maybe a lubrication. There's a bit of greasy residue on them, so we'll clean that off, and then I'll get to work on the EQ board before putting it all back together and testing it. So now we're on to another frustrating part with Mesa amps. Trying to get to this EQ board. So each fader has a little metal tab that comes through a hole and bends over on the front of the chassis. And obviously they want to hide that, so they put the faceplate over it, and they put double stick tape on each strip between each fader. So you got to try and remove this without removing the switches because they're bezel as well. So you can't. So you can only get them out so far, and because it was only designed to push them in, you can't get to the bottom to release the bottom side of the switch to remove it from the chassis. And even when you do that, the wiring's pretty tight, so you can only get them out so far, so you can only bring the front faceplate off an inch or so. So we'll see if we can just get to behind it enough to get to those tabs, and try and just bend them to get this board out without breaking anything or bending the faceplate. So to get to the bottom tab of these switches to get them out, I've got this little tool which is completely not for the purpose. This is what they call I think a harp hammer or something. It's got a little square drive socket on there for tuning harps and various other instruments that have, or some old banjos and stuff on the skins will have a smaller than average square drive sort of key, but because it's got an angle on it, we can get under there and see if we can release the bottom of that switch, which is hidden down behind the front of the angled chassis. And I think that's working. We'll get to the top one. And voila. Switch is out. We'll try that in the power ones and see if we can get enough room behind this faceplate to get to these faders. Really anything would work. You could bend a little piece of steel or something like that. That'd get you out of trouble too. I'm just trying to use whatever I've got within reach without having to reinvent the wheel. Alright, now those cables are tight, but that should give us enough play to just angle that faceplate out a little bit. I've just got my palette knife here to pry apart that tape. Put the faders all the way down for clearance. See if we can do it without breaking anything, eh? That's the name of the game. Yeah, it's not exactly a fun experience. It's about as fun as it looks. So I'll have to get in there now and clean up that tape because we've munted it all up. So here's a look at the pot casings, those slider pots for the EQ. Little tabs going through the holes there. We'll just have to gently bend them back. Hope to shit they don't break. And you've got to do that to remove the board to access the solder connections. So we're going to change those caps because they often fail. Like I said before in the previous video, it looks like one of the inductors has been replaced. The other inductors are floating above the board too, so they're wiggling them around quite a bit. Panny boy, focus, you can do it. There you go. So I'll push them down as far as they go, just reflow the solder, just so there's no threat of vibration or cracked solder joints there either. Alright, so here's the EQ board removed. Just bent those tabs only as far as we needed to get it out. We don't want to risk fatiguing the metal and snapping it off, but it gives us a good chance to inspect it, clean it properly, replace those caps, and just remove the overall grime and grease that's all over it. So peace of mind. So I'll remove this foam tape which is compressed and degraded and really gross. That's there to stop vibration against the bottom of the chassis. which this is pushing against when it's installed, so I'll replace that with maybe a long strip of neoprene foam when we reinstall it. So just these faders, they're really stiff, like the grease has gone all hardened in them and it's all coated with crap, so I might even give them a bit of a flush with ISO before re-lubricating them with some fader lube. Because yeah, if you went at that at a hurry, you'd probably snap that lever off, it's that stiff. Man, so much gunk and grime came out of these things. It was just chock-a-block full of it. Whatever the previous person used on them, it had either built up over the years or it was inappropriate to start with, because it was a real thick, heavy grease, and it was encrusted with all sorts of dirt and hair and gunk. But all of that's gone now after many, many cleaning cycles. Now you notice there's a little hole on the side. So that's like a little lubrication port, because it's got sort of like a kink in this plastic rail there that stops you from being able to access the strip down inside, the conductive strip. It's got a little, like a lubrication port in the side, so we can use our little bent nozzle and get between them and put a bit of lube in there. Just work it in. That's nice and smooth now. On to the next one. And repeat. Much freer. Alright, we've got the caps, new caps installed. It was a bit tricky soldering between the faders, but we managed to do it without melting anything, which is always good. The inductors are now seated properly. No real movement there. I've gone with 2 electrolytics for the relatively larger value, and then film caps for the smaller values. So we'll clean up the chassis, we'll get this in the main board reinstalled, and then we'll hook everything up, take some measurements, and see if we need to change anything else from there to get this thing purring. And we'll do some sound samples in the next one as well. I better practice guitar a little bit first, because I'm heavily out of practice. So we'll leave it here for this one. See you on the next one. And don't forget to like and subscribe, share it around. You know, if you're a true legend, you would have done it already. But, you know, there's always time for personal growth. So like, subscribe, and be a proper champion.